Assalamu alaikum. Welcome again on Fundamental of Soil Science course, first lecture. Today, I will explain cation exchange and cation exchange capacity. As you know from previous lectures that the soil has a negative charge, so it should be exchanged by cations on the surface of soil charge. The cation exchange is the exchange between cations in soil solution and cations present on soil surface. As you know, soil has a negative charge, consequently absorb or exchange positive charge which found on cations. The selectivity of cations by exchanger is based on the ion's charge and size. The smaller hydrated radius, the greater the affinity, as previously told you in previous lecture. Valence, the dominant factor influence adsorption or cation exchange. The higher the valence, the greater exchange preference. These show how cation exchange carried out if you have a plenty of potassium chloride and you have a soil particle exchanged by sodium. The excess potassium in soil solution can be replace sodium and exchange on the surface of the soil particle. The importance this process called cation exchange. The exchange between cations on soil solution and cations on the surface of the colloidal particle. The importance of cation exchange. The exchangeable K and M, for example, or calcium or copper, whatever nutrient is exchanged on the surface of the colloidal particle, are the main source of plant uptake. The plant can uptake this nutrient from the surface of colloidal particle. Reduce, the second importance is reduce loss of important cation through leaching process. Reduce mobility of some heavy metal through absorption processes. Consequently, prevent groundwater pollution and contamination because it's hold or absorb heavy metal or contaminated heavy metal on the soil and prevent it to go to leach to the groundwater and cause pollution. A very important reaction with an effect on the ability of the soil to resist the charge in pH value, the change in the pH value buffering capacity. Because if there is hydrogen exchanged on the surface, on the surface of colloidal particle, this exchanged hydrogen called reverse acidity, while hydrogen dissolved in soil solution called active acidity. When you are measuring the pH of the soil, you are measuring the pH in soil solution. Consequently, you are measuring the active acidity. If there is a change on hydrogen or decrease of the concentration of hydrogen in soil solution, the exchanged hydrogen is then can be released and caused buffering for the exchange, for the changes of pH. So if you have here, if you have H here, H instead of, imagine if there is H here instead of sodium, and you have this H called reserve acidity, while H in soil solution called active acidity. If these decrease for any reason, for example addition of lime or whatever, the hydrogen here can exchange to the soil solution and prevent changing on soil pH. This process called buffering capacity. So the ability of soil to resist change in pH, which called buffering capacity, is increases with increasing cation exchange capacity, the capacity of exchange. Please let me go through some quantitative expression of exchangeable cation. This may help you in understanding the cation exchange, or how you can express the cation exchange. The first is equivalent. I know that you should you should be known that this quantitative expression, it's a basic for you and important to be fluent on this quantitative expression. Equivalent means that the amount of material containing the number of Avogadros. Number of Avogadros is 6.23 multiply 10 to the power 23 electrical charge. So the equivalent, this the meaning of equivalent. It's quantity measured in gram. Yeah, it's the meaning of equivalent that the mass of the cation or molecule, whatever, of material which contain Avogadro's number of the negative charge or the electrical charges. The quantity is measured in gram and can be calculated by dividing the molecular or atomic weight in gram by the valence of substance, molecular or atomic weight over valence or charge per formula. So if you have sodium, for example, its atomic weight is 23, valence is 1, equivalent weight is in 23. Calcium, due to have two negative positive charge, its atomic weight 40, valence 2, and equivalent weight should be 2. If you have a salt of sodium sulfate, then sodium here has 2, or sulfate has two negative charge, and the molecular weight is 119, charge 2, and consequently equivalent weight should be 59.5 gram. The quantity of positive or negative charge here is the quantity of positive charge here or negative charge here. Charges in preceding 3 example is then equal this value. and all of these all of these and these called one equivalent of this substance or ion. Milli equivalent, one equivalent equal 1,000 milli equivalent, and this calculation it's easy. Milli equivalent, 1 milli equivalent of sodium will equal 0.03 gram or milligram. It's easy and should be well known. Part per million. What the meaning of part per million? Don't know. I think you know its meaning, but I will repeat again. Part per million or ppm. If I give you an example that you have a number of students equal 150, female 45, and then calculate the percentage of female and its parts per million or ppm. To calculate its percentage, it's easy. You have to divide 45 over 150 multiply 100 will equal the percentage is then 30. If you want to represent as the ppm female, then you have to multiply n 1 million part per million. Like the percentage is part per 100. However, ppm is part per million. So ppm should multiply in a million, 10 to the power 6 equal 30 multiply. So each a million of student contains 30 multiply 10 over 4 female. ppm equal microgram per gram, milligram per gram, gram per ton. This microgram per gram, in case the concentration on soil, and milligram per liter in case the solvent is water, because if the as you know, in soil solution, the element cations or anions and other elements are soluble on water. Consequently, when we said milligram per liter, the liter of water, so consequently these mean that milligram per liter mean ppm, but if the solvent is not water, then the milligram per liter will not equal ppm. Be careful. Okay, gram per meter cubic water also ppm. So what I would like you to know what the meaning of equivalent and milli equivalent per liter, how you convert milli equivalent per liter to ppm, conversion from milli equivalent to ppm, to convert milli equivalent to weight in milligram, just multiply to convert quantity milli equivalent to weight in milligram to milligram per gram. Milligram per 100 gram mean here is milli equivalent. Milligram per 100 gram will multiply equivalent weight of the